Hello everyone and welcome to iStructive webinar with the subject How to Streamline Your Structural Analysis. My name is Dr. Evelina Palkanoglou. Before we proceed to the session, I would like to introduce myself. My name is Evelina Palkanoglou. I am a structural civil engineer and I'm also a solution technical specialist at Greatech. I hold a PhD in computational mechanics from Loughborough University in the UK, and I studied and I got my degree from the National Technical University of Athens back in Greece. In this session, we will meet the capabilities of advanced design, the finite element software produced by Greatech. We will go through some major functionalities of the software, and then we will wrap up the session and give the basic conclusions. If all this sounds like a good idea, let's start. Advanced design is characterized as a game-changing finite element solution. I will present 7 major reasons why advanced design is such an amazing tool, a finite element software. I'll start with the first one. It's easy to use, easy to learn, easy to adopt. I would like to present these 7 reasons, and then I am going to elaborate those on the next slide. It covers a wide range of materials. The user can use concrete, steel, timber, can design, analyze and design non-common 3D structures and multi-story buildings. Of course, those materials can also be mixed in a project. So a project made of concrete with a steel roof, for example, is also something that an engineer can do in advanced design. Third major advantage of advanced design would be the data continuity between advanced design and any Autodesk software. Using specific tools, models from Revit or Advanced Steel can be transferred in advanced design for analysis and design and transferred back to the software that were originally made. The advanced design is equipped with a climatic load generator. There is a certain generator used to generate the climatic load, such as the wind and snow, very effectively. The software offers linear and non-linear type of analysis, seismic design with a lot of different options, the possibility to consider the construction stages during the analysis and design of the structure, as well as certain advanced computational capabilities. The software also supports both the European and North American norms. And last but not least, embraces sustainability with carbon indicators and timber design capabilities. Let's elaborate now. Advanced design is a user-friendly, easy-to-learn software. It has a CAD interface similar to AutoCAD, and the user can use this interface to create their model very effectively. Here we can see the grid, a steel frame made completely in advanced design, not transferred from another software. And the user can use the tools on this ribbon to create their model. the user can benefit from the easy modeling options of linear and planar elements, options to create vertical or horizontal elements, the same for the planar elements, vertical and horizontal planar elements, using literally one point to create them. The functionality of copying elements can also be used to create an array of different structure elements. It is quite beneficial to create large-scale or multi-story buildings very effectively and quickly. Since it has the CAD interface, has similar properties to AutoCAD, snap points, a lot of different options here to snap the different elements in the area the user prefers. And finally, multiple rendering options, so the user can benefit from the different render modes and use the ones that they prefer. Moving forward, staying, however, on the same subject about the user friendliness of advanced design, I am going to show you now the structure tree. It is a recommended way to work in advanced design when modeling in advanced design, and it has 4 major advantages. The first one enables the organization of different structure elements, parts of the structure. You can use different criteria to categorize the different elements in subfolders. Selecting a subfolder, you can easily hide and unhide the elements on the subfolder, so you can focus on different things while modeling. Selecting a specific subfolder, you can easily change the parameters and the properties of the elements in the subfolder. And finally, when having enabled the levels, the height of the different stories when modeling a multi-story building, for example, this feature can automate the construction phases functionality that is based on the different levels of the structure. On the right hand side, we can see a typical properties tab. Anything in advanced design has properties that look similar to those here. This is the properties of a linear element, a beam in this case. As you can see on the properties tab, the user can change all the parameters of this element to start, for example, with the material, the cross section. They can even change the boundary conditions, the mesh assigned on this element, and even the properties related to the design. This is very important, since the user can access the properties in one place, and they can easily change and adjust all the properties they want. They don't have to search for different areas, different places to find the properties they want. And also, having the structure tree organized, the user can change the properties of a variety of elements, of a group of elements, very effectively in advanced design. Moving forward, the second point on the slide when I presented the different advantages of advanced design, it was about the different materials covered. I'm going to show you 2 different structures now. Both structures have been awarded with an Advanced Design Award back in 2022. And I have selected those in order to show you not only how the materials were blend in those projects, but also the capabilities of advanced design to be used in very complex projects, very out of the box projects. So after this very promising introduction, I am going to move forward and start with the first structure. Here is a typical model of the structure, is in essence a tower, as you can see. And this is the model of the structure in advanced design. And now the details, of course. So it is the Kizera Tower in Poland. It is a mixture of steel and timber structure and received the third place Advanced Design Award in 2022. And the second one I have harvested for today. It's the structure you can see in this picture, and it's this one. And this is a photo of the structure before being built. This is the model of the structure in advanced design. You can easily see the different structure elements and some boundary conditions here on the model. And it's the Low Pasteur building in Monaco. It is a mixture of concrete and steel, and received the first place of Advanced Design Award back in 2022. We have a lot of customers of us in the UK where they have used the advanced design for complex projects as the ones presented with mixture of materials such as concrete and steel, or for example masonry and some steel elements. Advanced design has a lot of capability to support those structural materials. BIM workflow is also an advantage of advanced design. The data continuity between advanced design and other Autodesk products, it is a fact. On this slide, on this particular screenshot, I am going to talk about the workflow between Revit and advanced design. And this is enabled through a tool that is called PowerPack for Revit. We have the chance to discuss this specific tool in a few minutes. I have asked a colleague of mine to stop by and express their own opinion and comments about this. He's an expert on the PowerPack for Revit and explain the workflow. So, in essence, advanced design can ensure that any data coming from Revit can be transferred very effectively. The model can be transferred in advanced design, analyzed, designed, and then can be transferred back to Revit for further modifications. The tool that is used is the PowerPack for Revit, enables the analytical model, the creation of the analytical model and the transfer to advanced design. And then advanced design can after the analysis and design can export through specific tools. Again, you can export the model from advanced design back to Revit and do any further modifications on the non-structural elements. This is a typical screenshot that you can find in Revit when enabling the PowerPack that basically allows the export, import, or I would use probably the term synchronization between the two software. This is a typical Revit model. You can identify that. And I will show you how it will appear in advanced design if I want to transfer this model in advanced design. So using the Power Pack for Revit, the model has been transferred to advanced design. Only the structure elements have been transferred. Elements such as those that represent the foundations have been transferred in advanced design and identified as boundary conditions, which means that they will be treated as foundations later on during the analysis and design. On this screenshot, it's the same model using different render options where we can see small circles in different areas, and those ones can be highlighted in advanced design. We have specific tools for this. So any areas that there is a bad connection can be identified by advanced design, and you have tools such as those to adapt the model for finite element analysis. So the Power Pack for Revit plus the tools in advanced design ensure that there is excellent data continuity and the transfer is performed with minimum loss or even zero loss of data in the end. Now we have the chance to listen to my colleague Greg. Greg is going to talk about the Power Pack Revit. So let's enjoy Greg for the next a few minutes.
Hello. Eva asked me to drop by and help give you a quick overview of the Graitec Power Packs. We do a range of Power Packs for structural steel, Inventor, and of course Revit, which is what we're here today to have a quick look at. Hello, my name's Greg Benson-Shettle. I'm one of the many Graitec Autodesk certified trainers here at Graitec. Okay, so Power Pack packages. Now, even within just the one product, thinking about Revit, it comes in different flavors. So let's have a quick look. So we have different packages available. Looking at the list we have going across the top here, we have Power Pack for Revit, the SE, the Start Edition. And this has got all the basic tools, including some of the really powerful ones, such as our bi-directional link to Excel, which is, well, thousands of people are using this, and they wouldn't want to work without it. It becomes so useful to be able to review everything that's going on and add information to their spreadsheets. So we also have a fuller version which offers extended functionality for the Revit. So that's the full-blown Power Pack for Revit. And then we have some that are specifically for the structural engineers that are concentrating within the reinforced concrete arena. So we have Power Pack Rebar Detailing, and then we have Power Pack for Revit Rebar Design and Detailing, and that even adds even further tools. So here we have this PDF that's available, and as we scroll down we can see which tools are available. Now, even in the basic Power Pack for Revit, we have over 70 really useful tools, and I personally use them on my own projects. So I'm not just speaking as a commentator for Graitec. These are really useful tools. So just a quick scroll down, because I know my time is limited with you. So a quick look down, and as you can see, there's a huge list, and then we get into the more specialized areas for the reinforced concrete and the rebar detailing as well. Okay. And one thing, just a quick add-on, is that as soon as you move up into the slightly higher priced ones, they're not that, but the value for money, I think they're very good. You're also given gold support as a feature that's obviously, very useful. We sell Gold Support as a separate package all by itself in any case. Okay, let's have a look in Revit and see how that actually looks. Here we are back in Revit. So here's your Revit. I have a typical sample drawing in front of us for structural steel creation. This is obviously a 3D view, and we can see we have all sorts of connections and elements in here. Now, Revit itself, you have lots of tools, and including structural tools, so structural floors, beams, columns, and we've got connection tools in here as well, which have been imported over from the Advanced Steel package, which is based upon AutoCAD. Now, let's have a look at the Power Pack. So we can see running along the top of my screen here, I have an assortment of Power Packs installed. So they come in as a plugin, and if we click on the Power Pack, the main one, so this is the standard one, in here we can see a whole range of tools. Now, just to highlight a few of them that could be really useful in here. So there is a numbering tool. Now the numbering tool, let me go over to a floor view. So we have this automatic numbering tool. This is invaluable. You can go around and categorize any particular family, and you can pick up and you can specify how you want it to automatically renumber elements. We have introduced a series of tools in here, which we call algorithms, so you can choose how it goes round to automatically do this. However, whilst you've got the automatic ability to renumber things, you can actually use a selection order. So if you're looking at a small feature and you want things renumbered in a very particular way, you can do that. But when it comes to what can you renumber, based upon what you have in the model, you can pick up on all sorts of different elements in here. You can then decide what it's going to be you're going to go for. What is it you need to change? And you could give things a prefix, a suffix. You can set up how many numbers, what kind of numbering system. For example, I could say, right, I want a 3-digit number, and then there's the preview. Okay, you could give it a prefix if you wanted to. There we go. So I've got ABC 01, 02, 03, and then it will go around and redo it. So the renumbering tool is invaluable. It really is such a time saver. Some other tools that would be useful to you. Now, we have a structural steel here tool, which is the join, unjoin geometry. Now, I just want to highlight the fact that you can use this to make sure that joins are around the right way, and also could check that everything is the way that you expect. Now, notice that while I'm hovering over here, it says F1. So yes, there's a full help catalogue available with these particular tools. Okay, and if I press F1, it will actually go off and find that specific tool. So you've got lots and lots of help when it comes to using these. So not only are there the help packages, but you'll also find we've got YouTube channels with demonstrations, live demonstrations of all of the tools as well. So another tool that may be useful to be able to identify specific elements in here is an element lookup. Now, with the element lookup, we could incorporate some Boolean style selection options so that you can really pin down specific elements within your structural steel design. Okay. And then, as I mentioned, we have got our very, very famous link to Excel. It's a bidirectional link. Obviously, you know that you can export a schedule to Excel, but then when you do that with the Revit tools, that is a one-time opportunity. It's a snapshot in time. But if you use this tool, you can export your schedules out to Excel. You can make changes to that Excel, and then you can bring it back in to Revit And those changes, if appropriate, you can review them. You can make it will force the updates and make the updates happen. Now, we've organized it in a very sensible way such that, only suitable elements that are relevant and useful and unlikely to corrupt your model would actually be changeable. So that's just a real brief link. Now, of course, when it comes to analysis of software, we can use the advanced design link straight to our analysis software, which of course Eva's going to be telling you, I'm sure, a lot more about. Now, as I mentioned, just a couple of things, some other tools on the structural area, by the way. This one's really useful. You can detect errors. So what would happen is when you have your analytical style model, you can actually ensure that before you put it into your analysis software, you can check that all your analytical nodes are making good connections. So this will actually show and highlight those areas that need to be fixed if there are any. So we've got a whole bunch of structural additional tools in here as well. I mentioned about the reinforced concrete side of things. So if you go over and just want to show you quickly, we have the Power Pack detailing tools, and we have a whole range of create reinforcement tools, editing of the rebar, creating drawings for the rebar as well, and then we've got the Power Pack design. So in here we've got additional tools for geometry and creating groups, and we can do loads and combinations in here, reinforcement, and a whole deluge of other really powerful tools. Okay, so thank you very much. I know this was a brief whistle-stop tour around the Power Packs, but hopefully it gives you an idea about what we can do. This happens to be Revit 2024, but there are Power Packs available going back quite a few years. So if you are using, based upon a particular project that you've got to complete, if you are using a different younger version, or older version I should say, then you'll find that we have Power Packs available for those as well. Well, thank you very much. I hope you find the rest of the presentation useful. If you have any questions on the Power Pack or Revit at all, please feel free. You can email me. Okay, Eva can give you my email address. It will be, as you can see down here, we've got greg.benson-shettle@greytech.com. Okay, thank you very much. Bye-bye for now.
Before moving forward, I would like to thank Greg for this nice presentation of the Power Packs. Whoever wants to know more about the Power Packs, feel free to contact us, and we will arrange a demo for the Power Packs with more information about them. Moving forward to the climatic load generator that advanced design is equipped with. It is a widely applicable generator, allows the user to generate the climatic loads to simple and complex structures. We can see some of those. We have different types of roofs that the generator is applicable to. Rectangular structures, simple ones, buildings with horizontal setbacks, with or without parapets, vertical walls of rectangular plan buildings, and the wind can be generated and see the variation according to height. Multi-span roofs with or without parapets for multi-span frames. Wind can also be generated in outer panels, such as this one. And of course, we have the awnings and the protruding roofs, such as those presented here. And finally, the canopy roofs, either with or without parapets, monopieds, flat or inclined canopies or dual-pitched canopies. And finally, the option to generate and see the wind with, with its variation on lattice structures and scaffolding elements. The climatic load generator is also applicable to 2D structure, selecting specific options on the different elements. The user can see the climatic loads on 2D frames, for example, 2D steel frames. And this makes the climatic load generator very beneficial for the user, since it can be applicable to a wide range of structures. I mentioned earlier the advanced computational capabilities of advanced design, and it's about time to see those advanced computational capabilities. So, apart from the linear analysis, advanced design supports nonlinear analysis. Most of the nonlinear analysis can be established and see the user can see results related to geometrical nonlinearity. Advanced design does not support material nonlinearity, apart from the pushover analysis. I would probably add this comment here. Static nonlinear analysis to account for P delta phenomena, to consider nonlinear supports or any movement of supports or any supports with rotational or translational springs. The option to perform the analysis to get backlink loads for frames or compressive elements using the generalized backlink analysis. Second order analysis for cold form sections, and in general for any element that you would like to perform a second order analysis. Is under the advanced stability calculations, and allows the user to consider phenomena such as the wrapping or the distortion of an element. The construction stages I have already spoke about. The option to consider the fact that certain stages of the structure have been created earlier or later compared to others, and this might affect the results depending on the material of the structure, of course, or the structural system. So there is the option to consider that, and the engineer can check if the construction phases are changing the results. The construction phases can also be automatic. So depending on the levels of organization, how you have created your structure tree. If the user has enabled the levels, the construction phases can be automated, and basically each level, each story of a multi-story building will be considered as constructed in a different stage compared to the previous ones or the later ones. Advanced design is equipped with seismic analysis, so the user can perform seismic analysis and design. The seismic load is considered as a load case, so the user can design for the seismic load as well, can have combinations where the seismic load is considered as a specific load case, and export the results for specific seismic load cases. In addition to that, advanced design also holds the options to perform model analysis, pushover analysis for proportional collapse, and last but not least, time history analysis, dynamic analysis basically, where the user can add accelegrams or even make their own customized accelegram and get results of the time history of the displacement of specific nodes. The time history analysis is not limited only for the seismic design, analysis and design, but also can be used for other, to simulate, to model and get results for other phenomena such as any impact problems, for example, or any problem that the user would like to take into consideration the dynamic effects, or they would like to consider in their design dynamic response of the structure. Here on this screenshot, you can see the parameters of the seismic load case. And finally, the advanced meshing. Advanced design has a very powerful meshing tool. So the meshing generated on the elements, it is always very trustworthy and gives the best results. There are two different engines for two different algorithms for the method. The engine of advanced design that creates the mesh is very powerful. There are two different algorithms to create the mesh in advanced design, and of course advanced design supports different type of finite elements, triangular elements and quadrilateral elements, and the user has the option to select the one that satisfies their needs. Advanced design supports both the European and North American standards. This is basically enabled when selecting the location, when the user starts the project. The standards are automatically switched to the default option. However, they have the flexibility to choose alternative standards to apply to their operations. In this short video, we will see how this is performed in advanced design. So here we are changing the location from the United Kingdom to the United States. As you can see, the standards have been selected automatically. But now I'm changing to Canada. Again, the codes have been selected automatically to the Canadian ones. However, the user, for specific operations, they can change to another norm. Last but not least, the sustainable design. Advanced design supports sustainable design. We have a carbon emission estimations tool. The user can get the carbon dioxide emission on an element, per length, per volume. Here is a typical example for a steel frame. The cost estimation, so for each project, the user can plot and see the cost for each element. And finally, to support the sustainable design, we have nonlinear calculations to calculate the deflections of different elements. We are now moving closer to the end of this session, so I need to wrap up the session and express the major conclusions. So, advanced design is an easy-to-use, learn and adopt software for civil and structural engineers. It covers the design of a wide range of materials used in structural projects such as steel, concrete, and masonry. And the design can be performed based on different standards, both the Eurocodes and North American standards. offers excellent data exchange with Autodesk software such as Advanced Steel and Revit using the PowerPack tools. Its climatic load generator works for a range of different structures and can generate wind and snow loads very effectively. Supports advanced computational capabilities such as static nonlinear analysis, generalized backlink, construction stages, seismic analysis, and advanced meshing. And last but not least, the sustainable design. Thank you very much for your attention, and I am happy to take any questions from you.